Now, in this lecture, we find out the length of line segment X. In the drawing, we have a quarter circle. A or B is a quarter circle. Inside this quarter circle, we have a semicircle. This is a semicircle. And we also know that line segment AO equals to 10 units in its length. Our mission is to find out the length of this line segment AM, that's equal to X, according to what is given as the question. So first of all, we know that AOB is a quarter circle. Therefore, this angle AOB is a right angle. It is equal to 90 degrees in its size. And also side AO equals to side OB. They are both the radii of this quarter circle, therefore they are equal to each other. But it is given us the question that AO equals to 10 units, therefore OB must be also equal to 10 units in its length. And OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. Okay, so OB is the diameter of the semicircle. We define the center of this semicircle, this point, as point P. So now we know that OB is the diameter of this semicircle. Therefore, PB, that is the radius of this semicircle, must be equal to OB over 2. That is to say, it must be equal to OB, that is 10 over 2. 10 over 2 is 5. So the radius of this semicircle equals to 5 units in its length. OP, that is also the radius of this semicircle, equals to 5 units in its length. We define the point of tendency of tangent AM with this semicircle. This point is Q, and we join points P and Q together by a straight line. Point P is the center of the semicircle. Point Q is a point on the semicircle itself. Therefore, PQ is the radius of this semicircle. Therefore, it is equal to 5 units in its length. The radius PQ is drawn to point Q. That is to say, it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. In the next step, we will focus at this point, point A. Point A is an excellent point in relation to this semicircle. From point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, it says that the lengths of two tangents for a common excellent point to a circle are equal. We get that AO equals to AQ. But we know that AO equals to 10 units, therefore AQ must be also equal to 10 units because they are equal to each other. In the next step, we'll extend side AM and side OB by a straight line until they touch each other. So this is their touching point. We define their touching point as point N. By doing this construction, we created here the right big triangle, triangle AON. We define this angle as theta. We continue to focus on the right big triangle, triangle AON. In the right big triangle, triangle AON, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. In the next step, we'll focus on the green right triangle, triangle QPN. According to the same logic, in the right small green triangle, triangle QPN, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. In the next step, we'll prove that the big right triangle, triangle AON, is similar to the small green triangle, triangle QPN. Okay, so I write it down. The big right triangle AON is similar to the small green triangle, triangle QPN. So, why those two triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. This is angle AON in the big right triangle AON. And it is equals to this angle, that is actually angle PQN in the green triangle, PQN. Repeat again. Angle AON in the big triangle AON equals to angle PQN in the small green triangle PQN. They are both equal to 90 degrees. Therefore, they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles, so you can write down that angle theta equals to itself. So, if we relate to angle theta as it belongs to the big right triangle AON, it will be defined as angle ANO, and it is equal to itself. So if we relate to angle theta as it belongs to the green triangle QPN, it will be defined as angle QNP. Repeat again. This equation means that angle theta is equal to itself. We just called to angle theta two different names. Angle theta is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle OAN. In the big right triangle AON, and it is equal to this angle. This is actually angle QPN in the green triangle. Repeat again. Angle OAN in the big right triangle OAN equals to angle QPN in the green triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So it actually proves that all the three angles of the big right triangle AON are correspondingly equal to all the three angles in the right green triangle PQN. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. The big right triangle AON is similar. This is the sign of similar to the small right triangle QPN, and they are similar to each other according to angle similarity rule. And for the fact that the two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AO in the big right triangle AON over side QP in the green triangle equals to side AN in the big right triangle AON over side NP in the green triangle. Repeat again. We derive that side AO in the big right triangle AON over side QP in the green triangle equals to side AN in the big right triangle AON over side NP in the green triangle UNP. And it is also equals to side ON in the big right triangle AON over side QN in the green triangle. So repeat again. Now shall I find out that AO over QP equals to AN over NP equals to ON over QN. AO equals to 10 units in its length over QP equals to 5 units in its length, and it is equals to AN. AN equals to AQ plus QN. So in total AN equals to AQ, that is 10 plus QN. So in total AN equals to 10 plus QN. Here AN equals to 10 plus QN over NP. What is the length of NP? NP or PN? PN equals to PB plus BN. That is to say PN equals to PB, that is 5 plus BN. So in total PN equals to 5 plus BN. And PN or NP equals to 5 plus Bn, and it is also equals to On. What is the length of On? From the drawing it is very easy to see that On equals to OP plus PB plus Bn. That is to say, On equals to OP, that is 5, plus PB, that is 5. So in total, On equals to 5 plus 5, that is 10, plus Bn. So in total, On equals to 10 plus Bn. Here On equals to 10 plus Bn divided by Qn. Qn is the missing side, so we leave it as it is. In conclusion, found out that 5 over 10 equals to 10 plus Qn over 5 plus Bn, and it also equals to 10 plus Bn over Qn. 10 over 5 is 2. This equals to 10 plus Qn over 5 plus Bn. And it is equals to 10 plus Bn over Qn. Those two sides are equal to each other, therefore we create the equation number 1 from those two sides that are equal to each other. According to equation number 1, we get that 2 equals to 10 plus Qn over 5 plus Bn. Repeat again. According to equation number 1, 2 equals to 10 plus Qn over 5 plus Bn. Those two sides are also equal to each other, therefore we create the equation number 2 from those two sides that are equal to each other. So according to equation number 2, 2 equals to 10 plus Bn over Qn. So we're going to do two equations. Here we'll multiply this equation, equation number 1, by 5 plus Bn. And we get that according to equation number 1, two times 5 plus Bn equals to 10 plus Qn. Here we'll open the brackets on this side of equation number 1, and we get that according to equation number 1, 2 times 5 is 10, plus 2 times Bn is 2Bn, equals to 10 plus Qn. So here we have 10 on both sides of the equation, so 10 will get cancelled. After you cancel 10, we're left only with Qn, that is equals to 2 times Bn. That is to say, Qn is twice as long as Bn in its length. According to this equation, equation number 1, while according to equation number 2, we found out that 2 equals to 10 plus Bn over Qn. Here we multiply this equation, equation number 2, by Qn, and we get that according to this equation, equation number 2, 2 times Qn equals to 10 plus Bn. Okay. So according to equation number 2, 2 times Qn equals to 10 plus Bn. But according to equation number 1, we already found out that Qn equals to 2 times Bn. So we can substitute Qn in this equation number 2, by 2 times Bn. We'll do it now, and we get that according to equation number 2, 2 times Qn, and Qn is 2 times Bn. It is equals to 10 plus Bn. This side of equation number 2, we have 2 times 2Bn is 4Bn. That is equals to 10 plus Bn. Here we subtract from this equation number 2 Bn. And we get that according to equation number 2, 4Bn was Bn is 3Bn. So 3Bn equals to 10. Here we divide this equation number 2 by 3. And finally we get that according to equation number 2, Bn equals to 10 over 3 units. So this line segment Bn equals to 10 over 3 units in its length. So I write it down in the original drawing that Bn equals to 10 over 3 units in its length. This is according to equation number 2. Okay. According to equation number 2, Bn equals to 10 over 3. Well, according to equation number 1, we have already found out that Qn equals to 2 times Bn. So Qn equals to 2 times Bn. And Bn is 10 over 3. So it is 2 times 10 over 3. So Qn equals to 2 times 10 over 3, that is 20 over 3. So in conclusion, we found out that Qn equals to 20 over 3 units in its length. Okay, Qn equals to 20 over 3 units in its length. Yeah. This line segment Qn equals to 20 over 3 units in its length. In the next step, we will complete this quarter circle to a circle. So completed the quarter circle to a circle. And we'll extend line segment BO by straight line until it touches the circle. We'll define the touching point of the extended line segment BO with this circle as C. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 14. Rule number 14 is true in any circle. In any circle, if we draw two chords A, B, and C, D inside the circle, from the common point P, then the following equation will be true, that PA times PB equals to PC times PD. So we have in the drawing a circle, and we have the common point P. From the common point P, we drew two chords inside the circle, chord AB and chord CD. Both of them are drawn from the common point P. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We actually can implement rule number 14 in our drawing. Why? Because in our drawing, if we focus on the common start point N, from the common start point N, we have two chords inside this circle. We have chord MA. From the same common start point N, we have also here chord BC. Therefore, all the requirements of rule number 14 are met, and for that reason we can implement here rule number 14. According to rule number 14, NB times NC will be equal to NM times NA. Again, NB times NC equals to NM times NA. So I write it down. If we focus on the common start point N, we get that NB times NC equals to NM times NA. Repeat again. According to rule number 14, NB times NC equals to NM times NA. So first of all, we have to find out the length of line segment NM. This is line segment NM. From the drawing itself, it is very easy to see that the length of this line segment NM, it is equals to QN minus QM. QN minus QM. repeat again, the length of this 97 nm equals to Qn minus Qm. Nm equals to Qn minus Qm. So Nm equals to Qn. Qn is 20 over 3 here. Qn is 20 over 3 minus Qm. So in conclusion, we found out that the length of line segment NM is equal to 20 over 3 minus Qm. Now we return to rule number 14. Again, according to rule number 14, NB times NC equals to NM times NA. So NB is 10 over 3 times NC. What is the length of NC? NC and Cn are the same. So Cn equals to CO plus OP plus PB plus Bn. Again, but before that, we have to find out the length of line segment CO. Here, point O is the center of the circle, point C is the point of the circle itself. Therefore, OC is the radius of this circle. And the radius of the circle and the radius of the semicircle are the same because we just completed the radius of the circle and the radius of the quarter circle are the same because we just completed the quarter circle to a circle. Therefore, it is very clear that they have the same radius. But we know that the radius of the quarter circle equals to 10 units in its length. Therefore, the radius of the circle, CO, must be also equal to 10 units in its length. If CO equals to 10 units in its length. So, what is the length of line segment CN? From the drawings, it's very easy to see that Cn equals to CO, that is 10, plus OP, that is 5, plus PB, that is 5. So in total, 10 plus 5 is 20, plus Bn, that is 10 over 3. So in total, Cn equals to 20 plus 10 over 3. Then Cn or NC equals to 20 plus 10 over 3 units in its length. And it is equals to Nm. We just write down found out that Nm equals to 20 over 3 minus Qm times Na. What is the length of Na? Na is An. An equals to Aq plus Qn. Again, An equals to Aq plus Qn. AQ is 10 and Qn is 20 over 3. So in total, An equals to 10 plus 20 over 3. An equals to 10 plus 20 over 3. So according to rule number 14, we actually found out that 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. 20 times 3 is 60 and 60 plus 10 is 70. So in total, in the numerator of this expression we have 70 divided by 3 and it equals to 20 over 3 minus Qm. Here we multiply minus Qm by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So in total, in the numerator of this expression, we have 20 minus Qm minus 3 is minus 3 Qm. Again, in total we have in the numerator of this expression 20 minus 3qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to our current factor with 20 over 3. So here 10 times 3 is 30 and 30 plus 20 is 50. So in total, in the numerator of this expression we will have 50 divided by 3. Here on both sides of the equation we have 3 times 3 in the denominator, that is 9. Therefore we multiply this equation by 9 in order to cancel the denominator 9. So after we multiply this side of the equation by 9, we left only with 10 times 70 is equals to, here we left only with 20 minus 3qm times 50. Here we divide this equation by 10 and we get that this side of the equation we have 10 over 10, that is 1, so we left only with 70. That is equals to, on the other side of the equation we have 20 minus 3qm times 50, and 50 over 10 is 5. In conclusion, found out that $70 equals to 20 minus 3qm times 5. Here we'll open the brackets on this side of the equation. We will get that 70 equals to 20 times 5 is 100, and minus 3qm times 5 is minus 15qm. So in conclusion, found out that 70 equals to 100 minus 15qm. Here we subtract 70 from this equation and get that 70 minus 70 is 0, and it is equals to 100 minus 70 is 30 minus 15 qm. Here we'll add 15 qm to this equation and we get that 15 qm equals to 30. Here we'll divide this equation by 15 and finally we get that qm equals to 30 over 15 is 2. So qm equals to 2 units in its length. Here, this line segment qm equals to 2 units in its length. Repeat again that our mission is to find out the length of this line segment AM that is equal to x according to what is given us the question. So write it down. We have to find out the length of line segment AM that is equal to x. What is the length of line segment AM? From the drawings it is very easy to see that AM equals to AQ plus QM. Again, AM equals to AQ plus QM. So write it down. AM equals to AQ plus QM. This is to say AM equals to AQ, that is 10, plus QM, that is 2. We just write down formula that QM equals to 2. So in total, AM equals to 10 plus 2, that is 12. So actually found out that X that is equals to AM is equals to 12 units in its length. And that is the answer to our question. Yeah. This line segment AM that is equal to X, it is equal to 12 units in its length. So in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment AM, is equal to X according to what is given as the question. In the drawing, we have a quarter circle, AOB is a quarter circle. Inside this quarter circle, we have this semicircle. In addition, you know that line segment AO equals to 10 units in its length, and our mission is to find out the length of this line segment AM is equal to X according to what is given in the question. So first of all, here we on the drawing, we know that AOB is a quarter circle, and therefore this angle AOB must be equal to 90 degrees, because we are right angle. And we also know in any quarter circle, side AO and side OB are the radii of this the radii of the quarter circle, and therefore they are equal to each other. But we know that AO equals to 10, therefore OB must be also equal to 10 because they are equal to each other. So OB equals to 10 units in its length. OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So we know that the diameter of the semicircle equals to 10 units in its length. We define the center of this semicircle, this point as P. If the diameter of the semicircle is 10, it means that the radius OP must be equal to 10 over 2, that is 5. PB is also the radius of the semicircle, that is 5. We define the point of tendency of tangent AM with this semicircle as Q. Then we join points Q and P together by a straight line. Point P is the center of the circle, point Q is the point of the semicircle itself, therefore PQ is the radius of the semicircle, that is equal to 5 units in its length. Then we focused on point A. Point A is an external point in relation to this semicircle. From the common external point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they are equal to each other. That is to say, AO equals to AQ, but AO is 10, therefore AQ must be also equal to 10 because they are equal to each other. Okay. Then we extended line segment AM and line segment OB by straight line until they touch each other. They touch each other here, we define their touching point as point N. By doing this construction, we created the right big triangle AON. We defined this angle ANO as theta, and we continue to focus on the right triangle AON. In the right triangle AON, this angle equals to theta according to our definition. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we focus on the green triangle PQN. In the green triangle PQN, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta according to the same logic. Then we proved that the big right triangle AON is similar to the great triangle PQN. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the right triangle AON are correspondingly equal to all the three angles in the green triangle PQN. Therefore, actually proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that AO over QP equals to AN over NP equals to ON over QN. AO is 10, QP is 5, and it is equals to AN. What is the length of AN? From the drawing it is very easy to see that AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10 plus QN. So in total, AN equals to 10 plus QN. AN equals to 10 plus QN over NP. What is the length of NP? NP equals to PB, that is 5 plus BN. So in total, NP equals to 5 plus BN. Here, NP equals to 5 plus BN. And it is equals to ON. ON equals to OP plus PB plus BN. That is to say, ON equals to OP, that is 5, plus PB, that is 5, so 5 plus 5 is 10, so ON in total equals to 10 plus BN. ON equals to 10 plus BN. Here ON equals to 10 plus BN over QN. QN is the missing side, so we leave the CTs. In conclusion, we found out that 10 over 5 equals to 10 plus QN over 5 plus BN, and it is also equals to 10 plus BN over QN. 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN, and it is also equals to 10 plus BN over QN. Here, those two sides are equal to each other, therefore we get the equation number one from those two sides that are equal to each other. Those two sides are also equal to each other, therefore we get the equation number 2 from those two sides that are equal to each other. Okay. So, those are the two equations that we get from the long equation. Here we multiply this equation number 1 by 5 plus Bn. We found out that according to equation number 1, 2 times 5 plus Bn equals to 2 times 5 plus Bn equals to 10 plus Qn. Here we open the brackets on this side of equation number 1. We found out that 2 times 5 is 10 plus 2Bn equals to 10 plus Qn. Here we have 10 on both sides of this equation number 1. So 10 will get cancelled. We left only with Qn that equals to 2 times Bn according to this equation number 1. While according to equation number 2, we have already found out that 2 equals to 10 plus Bn over Qn. Here we multiply this equation number 2 by Qn, and found out that 2 times Qn equals to, here we have, according to equation number 2, 2 times Qn equals to 10 plus Bn. So we multiply the equation number 2 by Qn, we found out that 2 times Qn equals to 10 plus Bn. Okay, but we have already found out that according to equation number 1, Qn equals to 2 times Bn, so we can substitute Qn in this equation number 2 by 2 times Bn. We did it, and found out that according to equation number 2, 2 times Qn, and Qn is 2 times Bn. This equals to 10 plus Bn. So 2 times 2Bn is 4Bn. 4Bn equals to 10 plus Bn. If we subtracted Bn from this equation number 2, we found out actually that 4Bn minus Bn is 3Bn, so 3Bn equals to 10. Here we divided this equation number 2 by 3, and finally found out that Bn equals to 10 over 3 units in its length. Here this writes that Bn equals to 10 over 3 units in its length. This is according to equation number 2, while according to equation number 1, we already found out that Qn equals to 2 times Bn. That is to say, Qn equals to 2 times Bn, and Bn is 10 over 3, so it is 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So we already found out that Qn equals to 20 over 3 units in its length. Here, this line segment Qn equals to 20 over 3 units in its length. Then we completed this quarter circle to a circle, and we extended side BO by a straight line until it touches the circle at this point. We define the touching point of the extended side BO, and the circle is C. Point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of the circle. This is equal to 10. Why? Because the radius of the circle and the radius of the quarter circle are the same, because we just completed the quarter circle to a circle, therefore it is very clear that they have the same radius. Therefore the radius of the circle OC is 10. Then I presented to you rule number 14, and we implemented rule number 14 in our drawing. According to rule number 14, in any circle, if we draw two chords A, B, and C, D inside the circle, from the common point, point P, then the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing, if you focus at this common point, point N, from the common point N, we have two chords inside this circle, chord MA and chord BC. And according to, therefore, all the requirements of rule number 14 are met in our original drawing. Therefore, we can implement rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Repeat again, according to rule number 14, if we focus on the common point N, NB times NC equals to NM times NA. We have to find out the length of NM. From the drawing, it is very easy to see that NM equals to Qn minus Qm. Again, NM equals to Qn minus Qm. Repeat again, NM equals to Qn minus Qm. That is to say, NM equals to Qn, that is 20 over 3 minus Qm. So in total, NM equals to 20 over 3 minus Qm. Then we return to rule number 14. According to rule number 14, NB times NC equals to NM times NA. NB is 10 over 3 times NC. Here, NB is 10 over 3 times NC. NC or Cn, it is 10 plus 5 plus 5, that is 20, plus 10 over 3. So in total, Cn equals to 20 plus 10 over 3. Here, Cn or NC is 20 plus 10 over 3. And it is also equals to Mn. Mn is 20 over 3 minus Qm times An. What is the length of An or Na? An equals to Aq plus Qn. That is to say, An in total equals to A2 to Aq, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10 plus 20 over 3. An equals to 10 plus 20 over 3. So here we have 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3, then we divide it by 3 in order to make a common factor of 10 over 3. 20 times 3 is 60, and 60 plus 10 is 70. So in total, in the numerator of this expression, we have 70 divided by 3, and this equals to 20 over 3 minus 3 Qm. Here we multiplied minus Qm by 3, and then we divided by 3 in order to have a common factor with 20 over 3. So in total, in the numerator of this expression, we have 20 minus qm times 3 is minus 3 qm. So in total, in the numerator of this expression, we have 20 minus 3 qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3, then we divide it by 3 in order to work on factor of 20 over 3. So in total, in the numerator of this expression, we have 10 times 3, that is 30, and 30 plus 20 is 50. So we have 50 divided by 3. Here we have 9 on both sides of the equations. 3 times 3 is 9, so we multiply the equation by 9 in order to cancel the denominator of 9. After we cancel the denominator of 9, we left only with 10 times 70, that is equals to 20 minus 3 qm times 50. Here we divided the equation by 10. 10 over 10 is 1, so in this side of the equation we have to leave 70, and 50 over 10 is 5. So in this side of the equation we have to leave 20 minus 3 qm times 5. So in conclusion, we found out that 70 equals to 10 minus 3 qm times 5. Here we open the bracket on this side of the equation and found out that 70 equals to 5 times 20 is 100, and minus 3 qm times 5 is minus 15 qm. So in conclusion, we found out that 70 equals to 100 minus 15 qm. Here we subtracted 70 from this equation and found out that 70 minus 70 is 0, and it is equals to 100 minus 70, it is 30 minus 15 qm. So 0 equals to 15 minus 3. 0 equals to 30 minus 15 qm. Here we added 15 qm to this equation and found out that 15 qm equals to 30. Here we divided the equation by 15 and found out that qm equals to 30 over 15, that is 2. So here this line segment qm equals to 2 units in its length. Our mission is to find out the length of this line segment AM, that is equal to x. Here we have to find out the length of line segment AM, that is equal to x. For the drawing, it is very easy to see that AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. Again, AM equals to AQ plus QM. AQ equals to 10 and QM equals to 2. Again, AQ equals to 10 and QM equals to 2. So in total, AM equals to 10 plus 2, that is 12. So actually found out that AM is equal to x, it is equal to 12 units in its length. Okay, thank you very much.